In question 2, we're given the joint density function of x and y is 1 over a times y squared times x. And that's when y is no less than 1, and x is between 1 over y and y exclusive. And firstly, we're asked to draw the non-zero definition region of this density function. And that is to say we need to find out the defined area. So we need to find when y is no less than 1 and x is between 1 over y and y. And so here we can draw a very similar to the two axis graph here. And very naturally we can find when x and y is equal. And we can find when x is 1 over y. Because if x is larger than 1 over y, that means y is larger than 1 over x. And when y is larger than 1, that is to say from this point up, and then we need x to be larger than 1 over y, and that is so above this curve, above this line and above this curve. Here we have this almost like a triangle, but one of the sides isn't a straight line but a curved line. And second small question, we're asked to find a so that the joint this f of x and y is a valid joint density function. So pretty much this is to say if we integrate f of x and y, we need to get 1. And it's pretty simple. We just need to fill in the limit here, and that is according to the limit that is given here on the left, the defined region. Otherwise, f of x and y would be 0, would be undefined. So here we just have a little very easy calculus, and eventually we move all the constant out of this integral, and eventually inside the integral we have 1. So that means 2 over a is 1, and that means a is 2. Okay, third question, we're asked to find and draw the marginal density function of fx and fy. So fx is when we integrate f of x and y in terms of y. Right. So yeah. It's very easy, it's very clear to see that y has to be no less than 1. So y is definitely lower bounded by 1. But y is also lower bounded by x. And when x is larger than 1, x becomes the lower bound of y. So here we have a little discussion when x is larger than 1 or not larger than 1. And here we get two different functions here, and yeah, so pretty much when x is from 0 to 1, the value of fx is constant, is a half. And then from then on, when 1 is larger, or is no less than 1, we have 1 over 2x squared. And similarly, fy is to integrate f of x and y in terms of x. So here we have natural log of y over y squared. And then we have a graph like this, starting from 1 to infinity. And finally, I verify fnx and fx and fy are valid density functions. So pretty much, if we integrate fx in terms of x, we should get 1. And if we integrate fy in terms of y, we need to also have 1. And by doing a little math here, we can corroborate that it is true.